Hello, we're going to get restarted now. I'd like to introduce Andreas Färber to talk about SUSE Linux and all about it.
Thank you very much. So this is basically the end-to-end story of how SUSE is building software on the ARM architecture and how this allows us to cover a very wide range of different markets. For those of you who don't know SUSE, 2017 we've celebrated 25 years. So basically, the year after Linus Torvald launched Linux, SUSE was created. Unlike trends in the industries, we were recently bought by an investor group, and for 2.5 weeks now are an independent company again. And I'll start by going a bit into the product portfolio. There we go, sorry. The flagship product here is SUSE Linux Enterprise Server. And on top of that, you can see a number of software-defined infrastructure solutions being built, as well as some add-on products in order to manage deployments of server systems. There are also other variants besides the server product. Obviously, it doesn't make much sense to build a storage solution on top of a desktop operating system. Similarly, there are variants for real-time and point-of-service systems. And now, if you imagine a third axis to this diagram coming out of the screen, then we are using a common code base that is shared by this set of products across all architectures. So at the moment, our product is available, our current products are available for 4 architectures. And basically, this means that this product is available in 4 different variants over here. And we are an open source company, so besides Linux, our storage product, for example, is based on Ceph. Our management solutions are based on a Uni, Kubernetes, and so on and so on. All of our products coming from this background of not having started only with the ARM architecture are built natively. And we at SUSE, we love tools. So we have created an open source tool to build software. This is called Open Build Service. It's a client server system. There is a source server, a repository server for all the build artifacts, as well as a scheduler in order to arrange and automatically handle dependency resolution and rebuilds of packages as necessary. And then there's also a web interface in order to monitor the status of where the build process is. And of course, there is command line tools and also via the web interface, the possibilities to add new software, retrigger builds, and so on. This software setup has allowed us to also integrate QA processes directly into the build process. So when a set of individual packages gets built, some form of medium gets built out of those packages. In most cases, that is going to be an ISO image. And afterwards, this ISO image is being provided to our OpenQA infrastructure, which is yet again a small client server system that is scheduling test runs of predefined nature for a particular medium, and is therefore then assuring that also the outcome of the build automatically can get tested. Like I said, ARM on ARM. This means that after we had ported the openSUSE Linux distribution to AArch64, we were first using emulation technology. Then SUSE engineers set out to actually implement AArch64 instruction set in QEMU tool so that we could do a user space syscall level emulation only. And in the meantime, we are doing all builds natively on ARM servers. Some issues that have started to arise is that, in particular, when we're talking about building this software, there are certain resource requirements for doing that. So one is that for security reasons, we are using virtualization for isolation of the individual build processes. So we are, for each build, creating a reproducible environment of base packages, like a root file system that gets installed from packages to build on, so that anytime a software gets rebuilt, rescheduled to rebuild, there is a common set of base packages that this is being built on, and assuming that the source code of the packages is in a suitable form. You know, for example, that there are like no dates being embedded into the source code, then we also get reproducible binaries out of that. And if there are no changes resulting from a rebuild of the same package, then we can simply throw away the build results of that package and ignore that and take the previous version of that. I'll be getting back to how this affects customers in the end. Now, as far as the markets go for ARM, the first thing that got us into the ARM market was our storage product, so software-defined storage. Even when the CPU power was not close to what Intel servers would provide it, the I/O on ARM SoCs would allow to have storage-based solutions. This was the initial step that we took. And then from there on, we leaped to the very high end of the spectrum with Thunder X2, among others. We are currently working with HPE on the Catalyst project with multiple universities in the United Kingdom that are using SUSE Linux Enterprise Server or SUSE Linux Enterprise High Performance Computing in particular on the Apollo 70 systems. There were some pictures of such systems shown in Larry's presentation earlier today. And of course, these products, besides from different pricing models for particular markets, add additional software packages on top of the core operating system. For example, you will have like the Slurm scheduling package in our HPC offering. Then we had thought about how can we enable in this ARM-on-ARM world that is reality for us, how can we make sure that we can also start to reach a more enterprisey audience? And for us, this means that SUSE is working with a very large partner ecosystem, and it seemed key to us to enable all the ISV partners that we have in an Intel-dominated world today to also make their software available for our ARM-based products. And as part of our SUSECon conference, we made available as a gadget, a joke kind of, a demonstration of running SUSE Linux Enterprise Server on the Raspberry Pi as a piece of hardware that is like really inexpensive for people to put on their desktop, have like a minimal set of packages on there to boot it up to a desktop and attach a USB keyboard and just start coding and developing software. And the idea then is that if the software is developed for SUSE Linux Enterprise Server for ARM on a Raspberry Pi, you can deploy the same software also on all the full range of higher-end systems as well. We were kind of overrun by the interest this generated in the community, so that we then had to follow up by making this actually available as a supported platform within our SUSE Linux Enterprise Server products. And by now, there are also even one customer has agreed to share what exactly they are doing with this. So they have used like a standard Raspberry Pi together with a custom-designed hat and deployed this in large quantities in factories that they have in locations around the world, and are using this to collect data from previously non-connected like PLC systems in a factory, to gather data about how their production processes were moving on, like collecting sensor data and feeding this into an ERP system for data analysis. And this is one of the main things here that we're seeing, that people are trying to move computations or analysis code from their traditional data center into newer ARM-based devices, in addition to the infrastructure that they already had in place, and then exploring ARM in particular, and SLES for that as well. Now, when we are talking about building such a solution that would be deployed in large numbers in a factory, then no one wants to go and, apart from technical problems that I will not talk about here right now, no one wants to really reinstall hundreds of like Raspberry Pis or other ARM-based devices. So one tool that we have here is that traditionally SUSE had provided a service called SUSE Studio, which was a way to design by a web interface a VM appliance. So if you have virtual machines, you can simply design what exactly you want to have in your virtual machine, and then click on a few buttons and have that image be built by the infrastructure. In the meantime, this has been integrated into the Open Build Service software. And the main tool that is being used for doing so is called Kiwi. That is the what you can see on the right side here. This is a tool that takes as input an XML description of what should be part of the appliance that you are building. And then it simply creates a, usually again in a VM with OBS, a rootfs file system with a predefined set of packages that get installed and used for creating such an image. And this is then also what affects the customers, and that if they want to use those tools to build appliance images, then they also need essentially ARM systems to build those images on, because the packages that we have may at times also as part of the installation process try to execute some ARM-based tools as part of the post-install hooks. For one, some customers, to my surprise, have actually managed to use a Raspberry Pi with either a large SD card or some USB-based storage to build appliance images on that small device, or in other cases, they will just take an actual ARM server and use that for the build process. Of course, now with Packet and Amazon, there are additional vehicles available for making ARM server with more resources accessible to customers to use those for building their images and deploying them onto the devices that they would like to run the Linux Enterprise on. So that is about it. And with that, I'd love to go into the question part. Please.
So my understanding is that currently you're using your own server farm to both build and test your distribution. Are you planning to actually use cloud instances like Packet or Amazon in the future, or are you going to keep your farm? What's the direction there?
So for one, what I can share is that besides what SUSE is doing internally as a company, there is the openSUSE community distribution that our commercial products are being forked from. And this is available under build.opensuse.org. Several partners, including Marvell, have contributed hardware for that, and it is accessible to anyone who wants to create an account there and build and package software from there. That being said, for those instances that we run, we are not using cloud instances because we are under security certifications from multiple organizations, and having a link between external cloud-hosted servers and this internal infrastructure would cause problems for us. It should be possible to take the open source OBS software and deploy it within an Amazon or Packet instance if you want to use a private instance with your private data that you do not want to share publicly. I'm not aware of pre-made scripts like we saw in the session before to automate that, but I don't see any reason why it should not be possible.
Okay, any others?
So what I can share in the meantime is that we found that both of those tools that I was talking about, both Open Build Service and OpenQA, are quite a good tool for putting stress on the KVM implementations of the system and the virtualization instructions of custom implementations, because it is very heavy on interrupts, and if something gets lost or stuck somewhere, then it definitely gets noticed. It's not quite as easy to debug what exactly was causing it then, but it's been a very good testing tool as well for that purpose.
Any other questions? Okay, thank you, Andreas.